Hello. As they said, I'm Anna Migas. I work as a front-end developer and designer. I also hold the title of Google Developer Expert in the area of web technologies since the beginning of the year. And the title of my talk is Fast but Not Furious, Debugging User Interaction Performance Issues. During past few years, I've had a chance to develop and maintain free open source libraries. All of them were connected to animations. And during that time, I did really a lot of digging around performance because I didn't want to ship something that wouldn't be just smooth and performant for the users. And during that time, I read a lot. And I saw that there is one term emerging when it comes to performance, and this term is perceived performance. And while there is not one definition for perceived performance when it comes to web development, you could boil it down to two things. To first meaningful paint and time to interactive. First meaningful paint is a metric that tells us how fast user is able to see the first meaningful content on the page, and time to interactive tells us how long will it take before the user is able to interact with what was loaded. And if you started to search some further for articles on perceived performance, you would find things about how to optimize critical rendering path, which is basically taking a piece of code that is needed to load this first meaningful paint and things that are above default and extract them. Or how to use progress bars instead of spinners because users will feel that something is loading faster. Or maybe how to have a placeholder content like Facebook does. You have these gray areas that mark the places where content will be loaded any second from now. Or even how some pages start to upload the content before the user even knows they want to upload the content. Only they've just chosen the content in their media library on their device. And I must say, I don't agree with this definition of perceived performance. I feel that there's something more. I feel that it's not what we should call perceived performance. So let me tell you a short story to make it more understandable. Last year, I had a chance to fulfill one of my biggest dreams and reach the sacred valley of Machu Picchu after a few days of trekking. It was one of the hardest things physically I did in my life. And unfortunately, in the first day, I got very sick of altitude sickness, and there was no way I was going to make it on my own during the second day where we were about to climb a mountain. So I had a choice, either take a horse or go back to the camp. So of course, I decided to go up the mountain on a horse. And as it turned out, I was there very quickly and without much fuss, without much problems. And when I get there, there was snow, it was super cold, and there was nothing there. And it turned out I would have to wait for 40 minutes till the rest of the group got there because I was so much quicker. So the experience at the top was really horrifying. And I think that this is something that we have with perceived performance, that we care about loading things fast, like making them available for the user as fast as possible, but then we just leave them in the dark. So I think that what we call now perceived performance is actually perceived load performance. So as I said, loading things really fast and then just dumping the user into a website that can be kind of not usable. And I wish we all had something as real perceived performance, where we have the website that loads fast, and then the user is just experiencing amazing website. So I think perceived performance is not about first meaningful paint, time to interactive, but it's also about having our website smooth at all times. And this is something we're going to try to talk about today, how to achieve that. So I'm going to talk about why some interactions feel slow, about how the browser rendering process looks like, and then about the frames, about types of trigger changes in the UI, about how to test for interaction performance, and about some potentially dangerous UI patterns that are out there. So why sometimes interactions feel slow? The reason here is junk. Junk can be, in general, described as a lack of smoothness, as stuttering, of something that is not really fluid, not fluid movement. You usually see it in animations and interactions. And junk happens when the browser refresh rate doesn't hit the refresh rate of our device. So at this point, the most popular refresh rate of the consumer market devices is 60 frames per second. This means that if we divide 1,000 milliseconds, which is 1 second, by 60, we get 16 milliseconds, around 16 milliseconds. This means this is the time the browser has to create each frame. But there are some devices coming to consumer market that have even higher refresh rate, which is 120 frames per second, which leaves us with half the time we had before. These are namely the new iPads Pro and Razer gaming smartphones. So what it means? It means that if we want to support these devices with our, for example, animations, we would have to be even faster than we are now. And to be honest, we already have trouble with hitting the 60 frames per second threshold. And while in game development, it's already a standard to know the ways in between the frames, to make it easier for the device to render the frames, we as web developers don't know much about it yet. And I'm not trying to predict something, but if you remember what happened with high pixel density screens, when the Retina came out, we started serving the bigger images. Like we started trying to achieve the effect so that everything would look great on each device. So maybe at some point there will be more and more devices that have higher refresh rate on the consumer market, and we'll have to think about that. So how can we be more as game developers? How can we make it easier for the browser to make it on time with all the frames? What we can do is to offload the main thread. So by default, the browser has everything in one thread, and everything happens in sequence, and it can do only one task at a time. So if we have like really big JavaScript calculations, like really big calculations in JavaScript file, it might mean that it will offset rendering of the UI a bit. But there is also something called background thread, which is supposed to be helping us with really heavy tasks. So if you, for example, go to the page that is not fully loaded and you start scrolling, you can scroll and you see that content is getting loaded. This is because the scrolling is actually happening in background thread, because it's a really important task for us, and it was put there. So you can think of background thread as a bus lane, or, for example, VIP entrance to the party that is for really important things. So what we can do to offload the main thread, we can, for example, take advantage of web workers and put them and put some heavy JavaScript tasks into the background thread if we have them. But we're not going to talk about it. We're going to talk about how to optimize the main thread, so what is left after we take out these heavy calculations. So the bottom line is, if you interact with the page, the browser needs to start serving frames, be it 60 or 120 frames per second, ideally. And what the frame consists of, it's a sequence of steps. So we have JavaScript, we have size recalculation, we have layout, paint, and compositing of the layers. And it cannot be that we have paint step before the JavaScript, or we have layout step before the JavaScript. It needs to happen in sequence. So if some JavaScript jumps in after the layout stage, for example, then everything needs to get re-rendered. We need to start the frame all over. But, well, it sounds a bit like not understandable, but what browser is doing during these steps? So first, the change happens and an event is fired. It doesn't have to be JavaScript. It can be, for example, hovering or scrolling or clicking on a button that would change something. The next step is recalculating the styles accordingly to what just happened. We need to take some change. Then the layout is calculated. It can be. It doesn't have to be. So at this point, the browser is imagining the page as a collection of vector boxes and is trying to find out how much space each element is going to take and where it's going to be positioned. After the layout step, everything is rasterized and is painted to the layers. So we take our vector boxes and we put them into pixels. But what are actually layers? You can think of layers as of layers in Photoshop. If you have one thing on one layer and another thing on another layer, you can move them around and they're not going to be interrupting each other. But if you have two things on one layer, they're just glued together and there's not much you can do about them. So this is the same with layers in the browser. So you can take leverage of that and, for example, use layers for animation or interactions. But by default, the browser creates only one layer. And there are some things that will make the browser create more layers. Let's go through them. So first, there are 3D or perspective transforms. There are also 2D transforms and opacity, but they have to be animated. If they're not animated, there's no new layer. Also, if we have that's a child or is on top of already existing layer, it will be also promoted to another layer. There are also accelerated CSS filters that would produce another layer. In special cases, video, canvas, or plugins like Silverlight or Flash, because the browser will see, OK, there's going to be some video, there's going to be changing content, so I need to put it to another layer because this part of the website is going to be changing quickly. And also there is one property that lets us tell the browser, I know this part of the page is going probably to change a lot for the user, so maybe let's put it to another layer so that it wouldn't interrupt other parts of the page. And this thing is will change CSS property. To use that, you need to put the will change into your CSS and tell which property is going to be changed. One thing you need to remember is that you need to do it up front. So if you want to change something on hover, you need to actually use will change up front, just in a selector. And another thing is that you should use them wisely because every layer is consuming memory. So probably you're not going to see the difference on your developer MacBook. But some users with some devices that are not that powerful can actually experience even more lagging because we're trying to optimize things, or even the browser can crash if there are too many layers. So you need to find the right balance here. And then the last step is compositing. At compositing step, we take all the layers and we just glue them together into one picture, one frame that then is shown to the user. What's cool about compositing is that it happens always when you have more than one layer, and it also is happening on the GPU, so it's a bit offloading the CPU of the user. So it's also more optimal type of, more optimal step. But there are different types of trigger changes. Like some of them are more optimal and some of them are less. So there's some possibility to actually make our animations or interactions more smooth. So the first type of change is layout change, also called a reflow. At this point, all the steps are in the play because the browser needs to figure out how much space elements are taking, where they're positioned, and in general, it's changing the geometry of the page. It happens when we change properties like margins, display, margins, left, top. So this is a very heavy type of change, and these are definitely not the properties you should be animating. You should avoid this type of change at all costs. It's really giving you a lot of junk. The second type of change is a paint change, also called repaint. It would happen when we use properties like background color, background image, box shadow, color. So at this point, the browser knows exactly where everything is going to be positioned, and it knows how much space it's going to take. So we don't really have to go through the layout step. So as you can imagine, it's a bit more optimal type of change. Unfortunately, still, the paint step can be really a bottleneck of our pipeline, so it should be avoided also if it's possible. And then there is a compositing change. As I said, compositing happens on the GPU, so this is the most optimal type of change you can have. And it happens when we change properties such as transform and opacity. And with these two properties, actually, there's a lot we can do for animations and our interactions. So these are the properties you should be using for everything. So we talked briefly about how the browser rendering process looks like, but how we can actually test if we have a problem, if there are reflows or repaints on our page. So with reflows, it can be quite visible. If you have one element that is pushing another element away, or one element that is changing its size without using transform scale, then probably you'll experience reflow, and you'll probably see some junk even on your better machine. But repaints are not that obvious. For that, we need better tools. For example, this is from one of the libraries that I've built, and the repaints are happening on the 4 first stars on the left and not on the last star. And this is something I would never be able to discover without the dev tools. Why is that? Because the first 4 stars would overflow the text, and the last star wouldn't, so there wouldn't be a repaint. And developer tools in our browser are the best ways, are the best tools to actually test if we're experiencing some runtime performance issues. So first, you should go to the Performance tab. It's amazing. It's both in Chrome and Firefox. It lets you just record interactions on your page, and then it will show you just some statistics for that. So the shorter the recording, the better, because it's easier to debug. And then at the top, this green parts you see, I know it's a bit messy, but I will share the slides. This green part is the 1 frame, and it's how long it takes. So if you see some frames that are taking a long time, so way more than 60 milliseconds, or 8 milliseconds if you want to support 120 frames per second devices, you might click on this frame, and it will show you what takes the longest in each frame. And this is something you can start optimizing there. For example, it will tell you like some JavaScript is taking the longest. Then there is amazing layers tab in Chrome. It shows you live all the layers that are getting created and where they are positioned. You can have also like a bit like 3D view, so it really helps you to understand the stacking context of your page. And on the left, you have the information about each layer, and if you click it, you will know why each layer was created. So this is a really powerful tool. Unfortunately, it's pretty slow and heavy on your computers. So I wasn't, for example, able to record the video of how it works. So if your machine is not really powerful, you might actually go to the rendering tab in Chrome, which has a bit more things, and among them there is layer borders. There are also things like paint flashing, so it will show you which areas of the page are getting repainted. There's FPS meter if you wanted to see how fast your animation or interaction is running. So this is really cool. And if you enable all these things, it will look like that. Like this is the FPS meter that will show you the frames per second, and the green areas, it's what is getting repainted. So as you can see, if I scroll Facebook, it will just repaint all these parts of the page. So you can imagine that it's actually making a bit of a lag when you're scrolling and things are getting repainted all the time. In Firefox, if you want to see the paint flashing, you need to go to the settings, and there is toggle paint flashing option. And actually, you should test in both browsers, because things that don't trigger repaint in Chrome sometimes would trigger repaints in Firefox. So you should test in both tools. And then last but not least is the performance monitor in Chrome. If you just open it and start interacting with the page, it will show you like how much CPU you're using, if there are any repaints and reflows. And for example, if I were testing the page that was really optimized, there was a few % of CPU usage and no reflows, hardly any repaints. When I was using a page that was really slow and really not performing well, I had around 80 or 90% of CPU usage, a lot of reflows, a lot of repaints. So this is like very easy way to check if your page is slow or not. But these are like testing tools. And if your page is really big, it might be hard to actually spot the real problems. It might be hard to see where the problem lies. So what are the potentially dangerous UI patterns that you can easily detect on your page? There are some parts of the UI that are almost always bound to not look good if you didn't optimize them, if you didn't think about it up front. So let's go quickly through them. First thing is animations. If you have animation that is not optimized, you will see it like immediately after you know what junk is. So how can you fix it? Don't overuse animations. This is my first tip. If you don't have animations that would lead the user through the app, that would show some change in status, you might rather skip them if they're like purely for the graphics. You should also animate only transform opacity if possible. As I said, they happen in compositing stage on the GPU, so they are more performant. If you want to support this 120 frames per second animation now, you should avoid request animation frame. Even though it's a great tool, and in other cases you should use request animation frame. What will happen is some browsers don't really work as you would expect with this function. Some browsers have a cap of 60 frames per second for request animation frame, namely mobile Safari. So your animation won't ever hit the 120 frames per second in such setting. So if you want to support these animations, you should rather use CSS animations or web animation API. The other thing is to not animate elements that are below other nodes. Like, for example, if you have fixed element and something is animating below it, it would promote this thing to another layer, and you can experience some junk in there because of that. And you shouldn't animate too many elements. So even if your animation is like really performance, if you do it on 100 elements, it's not going to be performing really well. So if you're willing to, for example, put some snow animation on your page, falling snow for Christmas, you might want to think of smarter ways to do it than using 1,000 divs. OK. The second thing is my favorite, parallax effect. I was actually trying to search for like optimized parallax effect for one that is working fine, and this is what I found. It actually is not bad, but what you can see here, these green areas are getting repainted, and they're getting repainted on with every frame. This is something that is called paint storm, and as you can imagine, repainting whole page with each frame is not very performant. So, as I said, it causes paint storms. It's almost always bad. So if you can tell your client like there's not going to be parallax effect, it's perfect. You shouldn't use scroll events for that or background position because it will also cause paint storms. And if you really need to have a parallax effect, you should probably use 3D transforms in perspective trick. And here's a link to how to do it. I'll post the slides later. Then there are fixed elements, which are now on next to every page these days. And what happens is if we have fixed elements like this GitHub icon here, it just repaints with every scroll, with every frame on scrolling. Fortunately, there is a pretty straightforward way to fix it. You can use will change property or transform 3D property, which also creates layers. As I said before, 3D transforms create layers. And then it will not get repainted. It will be just on another layer, and it will not care if you're scrolling or not. Scrolling events. Most of us probably know that they are not the most performant thing you can do, like hooking to the scroll event. So what you can do about it, you shouldn't attach wheel or touch listeners to the whole document. If you can, you should rather use smaller areas for that. Also, you can take advantage of passive event listeners, but you should see if they're enabled in the browser before. And what it will do is like you just pass a passive true flag to your event listener. And why it's important. So by default, if you have scroll event, the browser all the time is anticipating that you might call prevent default. So there's a bit more work that browser needs to do, like thinking that at every moment you might want to stop scrolling. So if you pass this flag, you actually are telling to the browser explicitly, I'm never going to use prevent default in this function. You're safe. So the browser will actually, it can skip a bit of work on that, and it will be a bit smoother for you. Hover effects. Almost every page has hover effects, and most of the time they're harmless. But if you have too many, or if the areas that get triggered by hovering are too big, they can actually make the scrolling a bit more junky. So what we can do is, if we know that this hover effect is bound to happen often, we know that our user for sure will have to trigger this hover effect, we might consider putting there a will change property. But as I said, like, don't use too many layers, so you need to be careful of that. As I said, they can be deadly if there are too many, or they can be triggered too easily. And there's an amazing website by Paul Lewis, which tells you which property will trigger which step. So if it will cause a reflow or repaint or only compositing, so you can always use this as a reference if you're not sure. And last but not least, appending elements. I believe most of us had a chance to build a to-do app that would let us add elements to the list. What is happening if we append elements or we remove elements? The whole rest of the page context to the bottom will have to get repainted because we removed something, so the browser needs to repaint the rest of the page. What we can do, we can make sure that there are not many elements affected. So if we have a small page and only like one element is going to be affected by that, it's probably not going to be a problem. But if we're having like a big news site or something like that, and we're appending or deleting elements, then we might consider separating the context of this area so that we wouldn't repaint such a big part as the whole document, only the page part that is actually getting repainted. We can do it with will change, which we were talking about earlier, or contain layout, which unfortunately is not yet well supported, but if it starts to get more support, it's going to be great, because it's basically telling the browser, just separate this area, and nothing that is happening in this area should affect the things outside of this area, and nothing from outside of this area will affect things inside. So it's like a new context, which is great. Also, you want to probably not change the size of the area. So if you have, I don't know, some table or a list that is going to get some elements appended, you might want to just restrict the size of it, like with height, and use overflow property and with will change, and just have it separated. It might help. So the takeaways. Junk happens when the browser doesn't finish rendering a frame on time, so if it doesn't hit this device refresh rate. You should try to offload and optimize the main thread so that it would make it easier for the browser to make it on time with all the frames. You should avoid content reflows and repaints if it's possible at any cost. You shouldn't overuse layers to not crush the browsers of users that have less powerful devices. You should also test your website with performance layers and rendering tabs. This is really important. You should always test if what you're trying to optimize is actually making a change for good, because sometimes too many optimizations can actually give you the other, can make it the other way around. And you should use responsibly potentially dangerous UI patterns that we were talking about. There is a list of resources. As I said, I'll upload the slides later. And thank you.